a question from Signals and Systems, GATE 2020 paper. The pole zero plot of the transfer function of a system with input x of n and output y of n related by the input-output equation. This is the input-output equation. That is, the input-output equation is given. The pole zero plot for the transfer function is asked. So we'll just try to, this is the input-output relation given. K is equal to 0 to 3 minus 1 to the power of k into x of n minus k. I'll try to open the summation expression. Y of n will be equal to, k is equal to 0 means x of n minus x of n minus 1 plus x of n minus 2 minus x of n minus 3. Now to find out the impulse response, the transfer function, in fact, to find out the transfer function, let's say h of z will be equal to y of z by x of z. I'll take a z transform for this equation on both sides. It will be y of z, which is equivalent to x of z into 1 minus z to the power of minus 1 plus z to the power of minus 2 minus z to the power of minus 3. That is, h of z will be equal to y of z by x of z, which would be equal to 1 minus z inverse plus z to the power of minus 2 minus z to the power of minus 3. I'll try to factorize this above equation. It will be 1 minus z inverse plus z to the power of minus 2 into 1 minus z inverse. This would be 1 plus z to the power of minus 2 into 1 minus z inverse. Now to write it in numerator denominator form, I'll rewrite this as h of z is equal to, I'll just multiply numerator and denominator by z cube, which would mean z square plus 1 into z minus 1 divided by z cube. Now what are the poles? Poles are roots of the numerator. Roots of the numerator is z is equal to plus or minus j, or z is equal to plus 1. These are the zeros. Zeros are the roots of the numerator. Now what about the poles? Poles are roots of the denominator. Poles of the denominator is z is equal to 0, and in fact these are poles at origin, and the order here is, order would be equal to 3. Based on this, we'll have to compare with the pole zero pattern given in the options, and we'll have to conclude the answer. There are 3 zeros at plus or minus j and at plus 1. So if I observe here, this particular, there is a 0 at plus j, minus j, as well as at plus 1, and poles you have of order 3 at origin. So this would be the answer, pole of order 3 at origin. So option A will be the right answer. Option A will be the right answer to this question.